Hello and welcome back. I am Mr. Cobalt, and today we are going to go over the third problem for conversion factors and word problems. Again, the way we're going to attack this problem is we're first going to read the problem and pull out any information that they give us that we can use as conversion factors. And anything that is like something per something, or something where they're relating something to something else, you can write that down as an equality and then use that as a conversion factor when you start to solve the problem. But we need to pull the information out first, figure out where we're going to start and where we're going to end, and then once we get there, we set up the problem and go. So again, the first thing we're going to do is read through the problem, and we're going to pull out any information that we can use, any relationships, and then we're going to read the question, and the question will tell us where to begin and where to end. Once we have all that, we can start to solve the problem. So let's read the problem. It says 1/3 cup of vanilla ice cream provides about 146 kilocalories of energy. Okay, there's a relationship. So 1/3 cup of vanilla ice cream, ice baby, is going to be equal to 146 kilocalories of energy. 146 kilocalories of energy. Okay, so that's one relationship. Let's continue. A typical adult uses about 189 kilocalories per hour of energy while walking. Okay, so this here should send you a signal. We have kilocalories per hour, something per something. That's going to be used as a conversion factor. Okay, so the conversion factor is, let's see, we have for every 189 kilocalories of energy, that is equal to 1 hour of walking. Okay, so we have two equalities. That's going to be two conversion factors we can use. Okay, so keep reading. We're going to get to the question. So it says, if all of the energy in 1/3 cup of vanilla ice cream were to be burned off by walking, okay, so they're setting up the scenario. Now we get to the question. Remember, the beginning of the question where it starts off with how much is going to tell you where to end. So it says how many minutes, okay, how many minutes, so that's where we need to end. The number of minutes. So I'm going to write the arrow here. So we need to end in minutes. We're going to have a certain number of minutes. And we keep reading to figure out how, where we start. So how many minutes would it take for this energy to be used? This energy, what is the energy? The energy in 1/3 cup. Okay, so this one's a little bit trickier because they're saying this energy and you have to figure out what the this is talking about. The this is if all of the energy in 1/3 cup of vanilla ice cream. So the 1/3 cup of vanilla ice cream is where we need to begin. So 1/3 cup of vanilla ice cream. I'll just say vanilla ice cream. Okay, so now we know where to begin. We know where we need to end. We have a couple of equalities for conversion factors. So let's get into this. Okay, so I'm going to start. We need to start with 1/3 cup. So 1/3 cup of vanilla ice cream over 1. Now the 1/3 there is not going to be used in our calculation. That's just a 1/3 of a cup. So 1/3 of a cup is what we're starting with. Okay. So now we need to figure out our next conversion factor. So what do we say? We have 1/3 of a cup of vanilla ice cream is equal to 146 kilocalories. So we can use that to convert vanilla 1/3 cups of vanilla ice cream into kilocalories. So here we have 1/3 cup of vanilla ice cream. And then that's going to be on the bottom because I want to cancel that out. And then I'm going to put 146 kilocalories on top. So 146 kilocalories on top. So cups of vanilla ice cream, or the 1/3 cup of vanilla ice cream, cancels out. And now I have kilocalories. So now I need to convert to kilocalories. I need minutes, so I'm not done. So now I have kilocalories related to time, but it's in hours. But time is what I need, so that's what I need to do. So I'm going to use this. So I'm done with this one. And now I'm going to use the next one. So I've set up my conversion. I have kilocalories on the top. I want kilocalories on the bottom. 189. 189 kilocalories on the bottom. 1 hour of walking on top. So 1 hour walking on top. So kilocalories cancel out. Now I have hours, but I need minutes. So we need to bring in a relationship. Hours and minutes. We all know how many minutes are in an hour. So 1 hour is equal to 60 minutes. So I can use that to convert to minutes. So this will be my final one. So I'm going to put 1 hour of walking on the bottom and 60 minutes of walking on the top. So hours of walking canceled out, and now 60 minutes. I have minutes of walking. Minutes of walking is where I want to stop. So now that I have minutes of walking, I stop there. And now I can calculate the answer. So let's calculate that really quick. So this canceled out. So this is 1. So I'm gonna start by 146. So 146 times 1 times 60 equals, and then divide by what's on the bottom, that's 1. And that's 189, so divided by 189 equals. So I get, let's see here, I get 46.349, and we could say 20635. 20635. That's what my calculator spits out, but I can't keep all of these digits. I need to figure out how many sig figs I'm allowed to keep. So I go to my conversion factors and the numbers I used, and I get rid of anything that's exact, keep the measurements. So 1 hour and 60 minutes, that's an exact relationship. So that's true by definition. So that we don't need to worry about. Time and heat. So we're relating two different things together. That's a measure. So we need to pay attention to that. Heat and amount of ice cream, mass or volume or whatever you want, amount of ice cream, that's going to be a measure. Okay, so we're given 1/3 cup, a single third of a cup. So that's not going to be involved in our calculation or our figuring out of our significant figures. So the 146, the 189. So 189 has 3 sig figs. 146 has 3 sig figs. Remember, the rule is your answer, when you're multiplying and dividing, the answer you get can only have the same number of sig figs as the least number of sig figs in your measures. So since they both have 3, the least number is 3. So I have a 4, a 6, a 3. I cut it off here. This is a 4, so that stays a 3. I'm not going to round it up. So the answer is going to be 46.3 minutes. Minutes of walking. And so that is the answer that you would submit to answer this question or this problem. Again, I hope this was helpful. Again, to recap, when you're dealing with word problems and you're using conversion factors, you want to read the problem, pull out any relationships. Again, anything that is something per something, a unit per unit, that is going to be used as a conversion factor. Write it as an equality. Anytime they give you a relationship that says this is related to this, or something where they're making a connection between the two, write that down as an equality. You can use that as a conversion factor. Then when you get to the question will tell you 99 times out of 100, the question will tell you where to begin, where to end. And the ending is, again, given to you at the how many part. So right after it says how many, how much, what follows that is going to be the ending of your problem. And then if you continue reading, it will tell you where to begin in the problem as well. One thing I haven't mentioned, and I'll mention it now, is 99 times out of 100, you are not going to start with a conversion factor. The problem is not going to start with a situation where you have a unit over a unit. Those are going to be used as conversion factors. Those are not going to be used to start the problem. So never begin a problem with a conversion factor. I say 99 times out of 100, there will be a time maybe that you will start with a relationship, and we did see that with, like, for example, density. If you have density and they want you to convert density, the 2 units, into different units, then you got to start with the 2 units together. But 99 times out of 100, when you're doing your word problems, the word problem is not going to start with a unit over a unit. It's a unit on top, and then you use conversion factors to convert that unit to a different unit. Okay? So I hope this was helpful. Subscribe to my channel, like this video, share this video, ring the bell so you get notifications, and make comments down below if you want me to talk about something more or make another video on a particular topic. Let me know, and I'll try to do that for you. Thanks again for joining me, and I'll see you guys next time. Thank you.